Theoretical and practical questions of the non-invasive measurement of arterial stiffness. Part 3. Endothelial dysfunction and its relation to augmentation index. Defining the endothelial dysfunction, an excellent definition can be found in the JACC published by Anderson. The endothelial dysfunction is most often used to denote impairment of endothelial-dependent vasodilatation. Obviously, several other factors are contributing to cause endothelial dysfunction. However, for clinical point of view, it is very important to know that the endothelial dysfunction is primarily, it's a missing vasodilatation. In other words, it's a vasoconstriction, which is due to the determined and destroyed endothelial function. The biochemical endothelial nitric oxide synthesis can be seen in this picture. The major physiological factors to contribute to the endothelial nitric oxide synthase is the shear stress and the B2 adrenergic receptor agonism. Both physiological factors are increasing the production of the endothelial-derived nitric oxide synthase, which produces from L-arginine, which is an aminic acid, nitric oxide and citrulline. If this process is disturbed and the eNOS activity is reduced due to any reason, the nitric oxide synthase will be diminished. Thus, peripheral vascular resistance will increase due to the arteriolar and small artery vasoconstriction. Thus, the endothelial dysfunction is always accompanied with the increased vascular resistance, which we have to keep in our mind. And then, which is very, very important, with this very simple measurement with arteriograph, it can be detected as elevated augmentation index. We have scientific evidence that the so-called flow-mediated vasodilatation, which is the gold standard measure of the endothelial function, and basically the more the brachial artery dilates after a few minutes occlusion, and it is measured with ultrasound, the brachial artery diameter. So the higher the vasodilatation of the brachial artery after the release of the occlusion, the better the nitric oxide production in the endothelial layer, and then the better the endothelial function. In this picture, the authors measured simultaneously the arteriograph measured augmentation index and the flow-mediated vasodilatation with ultrasound. And we can see a very significant negative linear correlation between the flow-mediated vasodilatation and the augmentation index. In other terms, the better the endothelial function is, the lower the augmentation index. This proves that the AIX, the augmentation index, is not a stiffness parameter. The augmentation index is indeed a marker of the endothelial function, and this parameter, the augmentation index, is mostly maintained by the arterial tone and the peripheral vascular resistance. To show and to prove scientifically that the augmentation index is really a marker and the mirror of the arterial tone, the peripheral vascular resistance, we made a study when we wanted to produce isolated splanchnic visceral vasodilatation by food intake. So we measured the volunteers just before lunch, 30 minutes after the lunch, and 90 minutes after the lunch. Here are the results. We can nicely see that the augmentation index sharply decreased after the lunch in 30 minutes, and this kind of reduction of the augmentation index was kept on even after 90 minutes of the lunch. So the reduction in the augmentation index referred to the marked and significant visceral splanchnic vasodilatation. What happened with the pulse velocity? No change were seen, because before lunch, 30 minutes after lunch, and 90 minutes after lunch, the pulse velocity remained practically the same. So while these changes in the augmentation index were very, very significant, no change were seen in the aortic pulse velocity. The conclusion is that if we measure the augmentation index with this very simple method with arteriograph, we can measure the vascular resistance of the arterioles, and then it is basically equal to the measurement and the measuring of the endothelial function. Thank you for your attention.